Commercial air travel is old enough to have a history, yet imagine. Just 41 years ago, Henry Ford introduced the first all-metal aircraft, his trimotor, capable of cruising with 14 passengers at a breathtaking 100 miles an hour. By the early 1930s, the Curtiss Condor, last of the biplane era, was making scheduled transcontinental runs. Stewardesses had already learned to smile away the discomforts of cramped legs and tired bodies. After World War II, 4-engine airliners dominated the skies, lifting up to 100 passengers across continents and oceans. Now, hardly 2 decades later, the luxury of jet travel puts Paris only a coffee break from London and San Francisco, but dinner and a full-length color feature from New York. The next chapter in the brief history of commercial flight will be the new supersonic transport. Our story today on Science Reporter. Hello, I'm John Fitch, MIT Science Reporter. Today, we're at NASA's Ames Research Center near San Francisco, California, to learn about the next generation of commercial aircraft, the supersonic transport. 20 years ago, knowledgeable men were seriously wondering whether man could ever fly faster than the speed of sound. Debate ceased abruptly on October 17, 1947, when Captain Charles Yeager piloted his research craft, the X-1, through the sound barrier, thus marking the beginning of a new epoch in powered flight. Today, manned supersonic flight is commonplace. Military aircraft such as the versatile F-111, the giant B-58, or the mysterious YF-12A, to name only a few, normally cruise at speeds well over the speed of sound. And the experimental X-15 has briefly pushed even beyond the 4,000-mile-an-hour mark. But military and experimental design objectives are basically simpler than commercial objectives. Performance and mission accomplishment are their key yardsticks. Cost is secondary. Commercial airlines, on the other hand, naturally look first to questions of operating efficiency and cost. A supersonic transport must cost no more to operate per passenger mile than do today's subsonic jets. A transport must be durable, able to withstand continuous use for up to 15 years, and it cannot itself cost too much, nor can it require major alterations in existing airport facilities. Another factor of concern to SST planners is the sonic boom. Populations near airports and on flight paths are certain to protest a constant bombardment by shock waves. The British and the French were the first to commit themselves publicly to building a commercial supersonic transport, the jointly developed Concorde. The Concorde, scheduled to begin test flying in about 2.5 years and be in service by early 1971, is a fixed delta-wing craft designed to fly with 136 passengers at speeds somewhat over Mach 2, twice the speed of sound, or roughly 1,400 miles per hour. It has long been known that Russia also plans to develop an SST, and this model, unveiled at the 1965 Paris Air Show, provided Westerners with their first official glimpse of the Soviets' Tu-144. In 1963, President Kennedy announced that America would leapfrog the competition and develop her own larger, faster SST designed to carry 200 passengers at 3 times the speed of sound. Many tried methods of aircraft construction have had to be scrapped for the American SST. In the first place, aluminum, which is what most planes, including the Concorde, are made of, won't stand the heat created by friction with the air at speeds much over Mach 2. A sustained 630 degrees Fahrenheit is routine for a plane cruising at Mach 3. So hot, you could grill a side of beef on the leading edge of the wing. To meet the U.S. goals, aluminum had to be replaced by a totally new structural material. Finally, a lightweight titanium alloy with a melting point of 3,000 degrees Fahrenheit was selected. Having picked their material, engineers then could concentrate on a second major problem: aerodynamic design. Wind tunnel tests like this show that aircraft traveling faster than sound run into 2 types of drag. In addition to the normal drag of airflow over its surfaces, the plane compresses walls of dead air, shock waves in front of its surfaces. These shock waves can be observed and studied through a special optical system. In supersonic wind tunnels such as this one, engineers have found that a sleek and piercing design is most efficient. The fuselage must be long and pointed, the wings must be swept and flat like cutting edges. Finally, designers had to cope with a third major component of aircraft design, the engine. A new breed of jet engine had to be developed that would push out a little air at extremely high velocities rather than a lot of air at lower velocities. Using the basic research information from NASA's Ames and Langley research centers, two aircraft companies undertook the design of an SST. These radically different-looking aircraft are the results of their work. Here in Ames' 40 by 80-foot subsonic wind tunnel, the biggest in the world, large-scale models of these two configurations are being tested for their aerodynamic characteristics at slow speeds. To learn more about these SSTs, we talked to Mr. Mark Kelly, Chief of Ames' Large-Scale Aerodynamics Branch.
These airplanes are designed to cruise at nearly 2,000 miles an hour, which is more than 3 times as fast as our current subsonic jet transports.
Well, how's that going to affect the time, say, to go from New York to Los Angeles?
Well, you should be able to get from New York to Los Angeles in less than 2 hours. That's less than the time difference between the two cities.
You mean you could actually land before you take off, according to the clock?
That's right.
How many people will ride in one of these?
Between 200 and 250, depending on the mix between tourist and first class.
So we still have the 3 and 3 and 2 and 2.
Yes.
Seating and all that. 200 to 250 people means this is going to be a big plane as well as a fast one.
That's right. It will weigh about 500,000 pounds compared to our heaviest present jets are around 325,000 pounds.
How long will it be?
About 270 feet, nearly as long as a football field. Our present jets are about 150 feet long.
Well, since this is a supersonic airplane, why is it that you're testing it here in a subsonic wind tunnel?
Well, this is because no one wants to land at supersonic speeds. And in fact, the landing and takeoff requirements for the supersonic transport are quite stringent. It must have comparable safety, the same as the subsonic jets, and actually is required to make less noise than the subsonic jets. Specifically, our design objectives are to be capable of taking off out of a 10,500-foot runway on a hot day with an engine failed.
Really?
And the maximum takeoff speed is to be limited to 160 knots. The maximum approach speed is limited to 135. These conditions represent a pretty significant design problem for the supersonic transport.
Well, how are you planning to solve these problems?
Well, I can show this best by looking at the models that we have of the two different approaches to the supersonic transport. Well, this is a 1/5 scale model of the Boeing supersonic transport design. The pilots would sit up in this area. During landing and takeoff operations, the forward portion of the nose is moved downward to improve visibility during landing and takeoff. For cruise, it's up in position as shown here, and the pilots see out of these side windows. Now, the big feature of this airplane, of course, is the variable sweep wing, which we can show back here. This is the same principle that is used on the TFX fighter.
Oh, I see.
Now, the wing is shown here in its swept back position for supersonic cruise. This is approximately 70 degrees of sweep of the leading edge. There is a pivot in the wing in this general area which allows us to unsweep the wing to approximately 20 degrees of sweep for landing and takeoff operations. This allows us to generate the high lifts required to slow the airplane down. We can show you the wing configuration for landing and takeoff on the other side.
Getting a little old for this.
Yeah. Well, this is the way the wing looks during landing and takeoff operations. You'll notice, in addition to having the wing unswept, we have put leading edge slats on the forward portion of the wing. The purpose of the slats is to maintain a uniform flow over the upper surface of the wing. We also have trailing edge flaps on the aft portion. And these deflect the air downwards over the aft portion of the wing to generate as much lift as possible.
Now, why is it that you want all this extra lift during landing and takeoff?
This lift is required in order to meet the contract objectives of maintaining the takeoff distance less than 10,500 feet and maintaining the takeoff speed less than 160 knots. And we want to do this with as small a wing as possible.
Well, you mentioned a third objective, that is not to have the noise be any louder than with ordinary planes.
This is correct. And one way this is accomplished is through the use of larger engines, which we see here on this design. These engines have over 2.5 times the thrust of the subsonic jets. The airplane therefore can climb at much higher angles and will be further away from the community. This reduces the noise that the community receives.
Right.
Now we can take a look at the Lockheed model and see how another contractor has approached the same problem with a completely different design.
Right.
This is a quarter-scale model of the double delta fixed geometry supersonic transport configuration. Again, the pilots sit up in this area of the fuselage and the nose droops away for improved visibility during landing and takeoff operations.
What do you mean by a double delta?
Well, the wing, shown back, is comprised of two delta or triangular-shaped portions. This forward delta and the main aft delta shown here.
Well, now, if this doesn't change position, how do you get the extra lift that you need for this takeoff and landing problem?
This is obtained in a combination of three ways. First, this forward delta is used to generate a high-energy vortex.
So like a hurricane?
That's right, which generates a low-pressure field over the aft main wing.
Mm-hmm.
Then the wing itself is much larger than on the variable sweep airplane. And finally, we rotate the airplane to higher angles to
You
generate
actually tilt it up.
That's right, to a higher angle. When we do this, we lower these leading edge flaps to maintain smooth airflow over the upper surface of the wing.
I noticed that this plane doesn't have a horizontal tail like most airplanes that I'm familiar with.
Well, that's correct, and the tail is replaced by control surfaces here on the aft portion of the wing, all the way across the aft span. These are moved up and down to make the airplane go up and down, or one up and the other down on the opposing wing to roll the airplane.
Oh, and these are the engines under the wing?
That's right.
They're about the same as the
about the
plane
same
on the
thrust
airplane?
as the other.
Well, tell me, Mr. Kelly, have both these planes met these design objectives that you've been talking about?
They have come very close to meeting the design objectives, and I believe that with continued development effort, they will meet the design objectives at the
Still
end
got
of the...
some more work to do, right?
That's right.
Well, assuming they do, what will happen next?
Well, the next step will be an evaluation of the two designs by a government evaluation team with a recommendation as to which airplane should be taken into flight test development.
Mm-hmm.
There are people who recommend that the competition be maintained on both aircraft through a flight test stage.
Well, thank you very much, Mr. Kelly. In addition to static tests in a wind tunnel, some of the dynamic aspects of SST performance can best be tested in actual flight by modifying an existing aircraft to reflect various design ideas. Here at Ames, engineers have taken this F-5D, for example, and changed the shape of its wing to resemble that of a delta-wing supersonic transport. Thus, they can test the lift characteristics at low speeds of this proposed SST design. The F-5D has a 5-year history of flight testing various design ideas. Here it flies missions in the critical region of subsonic flight, testing the low-speed lift and stability characteristics of this particular wing shape. Even at these subsonic speeds, the wing edge condenses moisture in the air that crosses it. The resulting vapor creates visible patterns of the vortices which are produced and which provide even more than the expected lift at slow speeds.
America's newest research craft, the controversial XB-70, has pioneered in high-speed test missions. 2 years ago, it was to go into production as the most up-to-date member in our arsenal of long-range bombers. Once Congress canceled the bomber program, NASA and the Air Force agreed to use the two prototypes jointly as test craft. Although because the XB-70 is expensive to build and operate and has only limited payload capacity, it can never be used for commercial travel. Flying 3 times the speed of sound at 70,000 feet, about the same speed and altitude the SST will cruise at, this huge white bird now gathers invaluable data on stability and control characteristics. At the same time, cruise missions check out engineering solutions to the most difficult problem of high-speed flight, sustained heat. Hydraulic systems, electrical wiring, bearings, and seals have all been redesigned to withstand the scorching temperatures. Tests also gauge airframe strains and fatigue under these extraordinarily demanding flight conditions. As the only large experimental aircraft able to cruise at Mach 3, the XB-70 has a busy schedule, and much of the information gained on these flights will be directly applicable to the SST. This plane, now coming in for a landing, has a long history of contributions to in-flight research. It's a Boeing 707 prototype. In fact, the first 707 ever built. In its day, it held the transcontinental speed record. But much of its long life has been spent playing charades. After flying countless missions for 707 testing, engineers, with a wave of their wand, miraculously turned it into a 727. Now, here along the coast of Virginia, where NASA is testing the handling and maneuverability of the two supersonic configurations, it pretends to be an SST. To learn more about this versatile plane and the tests it's performing, we talked to Mr. Robert Shade, project manager for SSTs at Langley Research Center.
Mr. Shade, that was a beautiful landing. How are you?
Thank you.
What is the purpose of this rather unusual-looking airplane?
Well, the purpose is to simulate supersonic transports during the landing approach with a large subsonic jet transport.
Well, now, how can you do that? I mean, this is a subsonic transport. It looks very much like a 707.
Well, it looks like one, but it doesn't fly like one. We have inside the aircraft a computing system that takes all of the aircraft's inputs, like the pilot's control and the movements of the aircraft, into the computer. The computer analysis of the thing tells the controls what to do to make the airplane fly, just like a supersonic transport.
I see. So there's a computer between the pilot and what actually happens.
That's right.
So that if he pushes some normal control, it doesn't respond just the way he might expect it to.
For example, if he pulls the control column back halfway, the normal airplane you see there would pitch up rather rapidly.
Yeah.
But after it goes through the computer takes some of this out, so it pitches up a lot more slowly, like a real large supersonic transport would.
Which couldn't possibly respond as fast as a
That's
slower
correct.
plane. What is the inside that nose that sticks out like a beak?
Well, that big boom you see back there is our angle of attack, which is for the airplane going up and down, and angle of side slip indications.
Mm-hmm.
And when this aircraft moves either up or down or back and forth, this little vein right on the very tip end of this boom transmits signals back to the computer, and then the computer takes these signals and uses them for the simulation.
I see. That really tells you what the plane is doing.
That's correct.
But if the pilot can see out the window, I think that would tend to spoil the effect. I mean, does it really feel like he's flying at supersonic speed?
The only thing that he does not feel is that the pilot is closer to the center of gravity of the airplane. He's not quite as far out in the front. Mm-hmm. Otherwise, the airplane motions, the movements he goes through, and most of the visual cues he has are essentially the same.
What kind of men do you use for flying this? Or regular pilots? Or?
Well, we have been using 2 of our NASA research pilots to conduct this low-speed landing approach evaluation, and right at the present moment we're using 4 outside pilots to evaluate it to get a more comprehensive indication of what we have done.
What's their reaction to this peculiar interference with their normal controls?
Well, most of these people that are flying it are pretty well versed in terms of test pilots, and they're used to this sort of thing, and they can sort out the good and bad things and tell us what we have here in the way of a supersonic transport.
Well, now, can you try different designs, sort of program them into the computer so that
Definitely.
it isn't just any supersonic transport?
We have a big patch board, it's about this square, that's just covered with wires. We call these computer patch boards, and when we fly a given configuration, the patch board is pushed in to the computer, and this computer then responds to this particular configuration. If you want to change from a variable sweep SST or supersonic transport to a delta configuration, you just take the patch board out and put another patch board back in, and then the airplane flies like the other configuration.
Is it too early yet to say which designs look promising?
Well, all I can say is they all fly.
They all fly. Is part of the purpose of this to see whether pilots can actually handle these airplanes?
This is the biggest thing we're after. We don't know for sure until the actual airplane is built whether the supersonic transports will fly like we think they will. And this is just the next step we're trying to do here to get a better feel for what the SSTs will be doing when they fly.
Not all SST testing is best done in the wind tunnel or in the air. Often engineers want to try out a whole variety of conditions, including some that might prove unsafe in flight. To see how these tests are conducted, we talked with Mr. Seth Anderson, Chief of the Flight and Simulation Branch here at Ames.
As you can imagine, it's rather expensive to operate a large jet transport. For that reason, we do quite a bit of our work with ground-based simulators. In this way, we can cover a broad range of parameters and then use the flight test results to validate the ground-based results. We have one of the simulators here.
Oh, is this a supersonic transport?
It's a cab that's used to represent some of the supersonic transport's characteristics. This cab can actually move. It rolls plus or minus 12 degrees, pitches up and down, and moves through an altitude range of about 3 feet. This gives a pilot a lot more realism, a much better feel of actually flying an airplane than if he were standing still.
So he's flying by the seat of his pants.
That's correct.
Now, what does he see? A movie of a typical flight path on the screen?
No, it's not a movie, John. It's a projection of a landing that's given by the projectors on top of the cab through a closed-circuit TV system.
Television.
And it's actually in color to add more realism again. And this equipment is in another room. And the camera is driven over a landscape to show his approach to his landing and to the actual touchdown on the runway.
Actually, when he moves the control in the cab, does that sort of move the camera over the landscape?
Well, not directly. We do have to go through a computer setup to give the actual supersonic transport's characteristics.
Oh, I see. So when he moves the control, it may not respond instantaneously. It responds more like a big sluggish airplane.
That is correct.
Could we see this in operation?
Why don't we take a ride?
Okay. Would you go first here?
As you can see, this is the most important part of the cab. Only where the crew is actually operating. Why don't you sit in the co-pilot seat, and we'll have a preview of an SST aircraft making a landing.
I've never even had a chance to do this in a regular plane. This is great. You got all the instruments here that you would in a SST?
As you can see, we don't have a full set of instruments. We have only those that are required for our research purposes. Are you ready in the computing room?
Roger, anytime you're ready.
Here we have the altimeter. As you can see, we're starting out at 1,000 feet. We'll be making our approach at 130 knots.
Oh, so we're not supersonic coming in here. We've slowed down a lot, all right?
This is the final portion of a supersonic flight, and you'll be given a little bit of an idea of how it looks to approach with this large aircraft, and I want you to note in particular the response for this type of a vehicle.
Okay.
If you're ready, we'll go ahead.
Fine. Let's go.
We're now in motion, making our approach at roughly 1,000 feet. We'll be coming down on the glide path now at 500 feet per minute.
Is that the airport there ahead?
The airport's directly ahead. I'll give you a little idea of the maneuver.
Oh,
This vehicle. We'll start over to the left and make an offset correction before we get down to the runway.
I can really feel that. I see what you mean. It does respond very slowly when you
Yes,
change its control.
remember, this is a very large aircraft,
Right.
and the response of a large aircraft is necessarily slower for safety and structural reasons. We'll actually overshoot the runway and come back and get lined up. You can see we make a correction to go up if we're too low and go down if we're too high.
Can you make this behave like a delta or a swept wing or any type you want?
Yes, by proper adjustment of the stability parameters, we can simulate any of the supersonic transport configurations.
Now we're getting...
For now, we're just a little bit above glide path. You can see the runway directly ahead of us.
About less than 300 feet.
This approach is being made under visual conditions, but you can imagine that the entire approach down very close to the ground could be made under instrument conditions.
We're about ready to touch down?
About ready to touch down. There we are on the runway.
I could even feel it touch.
You can notice the light that comes on to indicate that we're actually on the ground.
Well, that was a very smooth landing.
That's just typical of the many landings that have been made to ensure that the supersonic transport can carry out a mission in a safe and efficient manner.
Well, thank you very much, Mr. Anderson. Once the testing has been completed and the results evaluated, the decision on a specific version of the SST can be made. By 1974, America's supersonic transport should be in the skies. But as progress would have it, this newest of airplanes is already, in a manner of speaking, becoming obsolete. Research is even now underway on the next generation of vehicle, one that feels most comfortable at speeds between 6,000 and 16,000 miles an hour. A thin, rocket-shaped scramjet, the hypersonic plane they call it. No longer seems even improbable that one day, New York to London may be measured in minutes. I'm John Fitch, MIT science reporter.
Hello everybody, welcome to the AV Geeks lunchtime streaming show. I am Skip Elsheimer. Thanks for joining me today. So that last film was Ticket Through the Sound Barrier, which was part of this Science Reporter TV series. We saw one called Suited for Space, I believe. Did we watch that one? Yeah. Which basically talked about the challenges of making a spacesuit for people that were going to go leave Earth's atmosphere. This one's great because this is dealing with high-speed air flight and is hinting at the Concorde, which appeared and then disappeared. It's kind of interesting to me. I like looking at what the projections are. Here's this possible thing that we have. Of course, the downer part of this is the fact that it was incredibly loud, required super long landing strips. There was a financial cost that I don't think that they were able to justify over a period of time. Like, they couldn't make enough to actually I don't know. There's a lot of factors that led to the SST not existing anymore, and certainly us not traveling by air so much makes it even more difficult. But this is a great opportunity for me to bring up the fact that I've been calling myself AV Geeks since the early 90s. And I would say probably in the early 2000s, or maybe even the, like 2010 or so, maybe even later than that, 2015, I started seeing people using the hashtag AVGeek, and I was like, what is this in reference to? And it was aviation geeks. Aviation geeks have tried to take over everything, and in fact what they did is they actually took over some of the names on YouTube, they took over some of the hashtags, so I am not mad, but it's like, dude, if you're aviation geeks, why don't you call yourself AVI geeks or something else? Like, AV is audiovisual, and I've been around forever. So, like, why are you doing this? So anyways, occasionally I do shows that are about aviation stuff, and I actually talked to someone in Houston about doing a show in November, virtually. It's about commercial air flight. So there is this weird overlap. So I've been kind of playfully dabbling in that, but it is annoying to just have somebody kind of swoop in and say, like, yeah, AV Geeks, that means not audiovisual, that means aviation. So, I mean, the fact that I'm doing a daily show called AV Geeks is probably enough that it's clogging everybody's feeds that are looking for AV Geeks, so for aviation stuff. So there you go. We're going to try an experiment where I'm going to play a silent film and I'm going to play a soundtrack behind it. And the challenge, of course, is, like, I would love to play you some production music stuff, but that's immediately going to bring a hammer down. So I brought something that is thematically related and probably won't, I'd be surprised if it registers. It's by Boyd Rice, who did amazing noise and sound work in the 80s before he became problematic as a person. But I still like his sound and noise work. So here is one of those films, those time rating studies films, where efficiency experts would watch how somebody does something, manufacturing something manual and manufacturing-wise, and tries to come up with ways to, one, grade the person to see if they're good at it, two, come up with ways to make it easier. And so I have a series of test studies where people that are being trained in advancement of management via efficiency studies and motion studies can grade. So here are people doing things, manufacturing things. Now, I showed one of these months ago. I don't think this is the same one. I feel like, because I have like 5, maybe even more, but I feel like this is different. This is from film. So there's a lot of talk. Let's watch some people do some stuff. Enjoy. All right, you get the point. Really amazing footage. The thing is, it runs at 18 frames a second, which is not sound speed, that's silent speed. 16 millimeter was usually shot, if it was silent, at 18 or 16 frames a second, or sometimes even lower. Some people had a camera that would save, you could do 12. So, people would save film that way, but it's more herky-jerky that way. So I added a soundtrack by Boyd Rice, his group Non, basically did skipping records and tape loops, and was in that genre called industrial music, before industrial music was dance music. And it fits, man. It fits totally well. It feels like you're in a factory with those people, in my mind. So thanks for indulging me with that. Let's see. What do we got next? It's time to go to the circus. So here's Circus Day.
Welcome to Clown Alley. This is where I get ready for the big show. It's Circus Day in a big city. Out front, the people are gathering here at the sports arena for the afternoon show. Today's big circus plays in a building of concrete and steel. But when I joined the circus, we played under a huge canvas tent. Those were exciting times. The circus day began early in the morning when the circus train pulled into town. Back then, I was traveling with the Cole Brothers show. A large crew of workers traveled with the show. They worked together as a team to unload the train and set up the circus lot. The workhorses were unloaded first. Old Tony was a real ham and always greeted the circus fans with a fine bow. They used the horses to unload the heavy wagons. A rope wrapped around a snubbing post kept the wagons from rolling too fast. As soon as the wagons had been rolled from the flat cars, They were hustled away to the circus lot. There were many animals to be unloaded. The elephants were carried in cars that were higher and stronger than the other stock cars. I guess elephants and the circus have always gone together. Circus people prefer to use Indian elephants because they are easy to train. The elephants are called bulls, and the trainers control them with a pointed stick called a hook. We carried animals from all over the world. There was a sacred bull from India, and llamas from the high Andes mountains of South America. There were zebras from the wide grassy plains of Africa, and camels from the plateaus of Central Asia. Signs had been drawn with chalk to direct us to the circus lot. As the animals arrived on the lot, they were tied to wagons until the menagerie tent was ready. Wagon after wagon was pulled into place. Lots of work had to be done to get ready for the afternoon show. The biggest job was getting the canvas into the air. Hundreds of stakes had to be driven into the ground to tie down the tents. Some of the stakes were driven by hand, but most were driven by machine. The center poles had to be threaded with pulleys and ropes and large iron rings to hold the canvas top. The first center pole to go up was called the king pole. The king pole was held in place by long guy ropes and was used to help raise the other center poles. One by one, the elephants pulled the heavy poles into the air. The men had been working since early morning and were sure happy when the blue flag went up on the cook tent to signal that breakfast was ready. We were one big circus family in those days. Our cooks prepared only 2 meals a day, but there was plenty of good food, and you could have all you wanted to eat. After breakfast, there was still a lot of work to be done. Roll after roll of tent canvas was pulled from the wagons. The elephants were trained to do many jobs and were a big help in putting up the tents. After the canvas was spread, some of the workmen tied it to the iron rings, while others laced the sections together. When the canvas was ready, the men set the side poles.
Come ahead with the pole, up high, to the hole, shoot it, move along.
As pole after pole was raised into place, the big top was slowly lifted into the air.
One, two. Hit it, hit it, hit it, hit it, hold it. Now downstage, hit it, next.
Finally, the seats were set up and the side walls were hung in place. When the tent was in the air, it was easy for anyone to see why we called it the Big Top. By noon, all the tents were ready and the animals were under cover. The heavy work of the elephants was done, and they had time for a well-earned rest before the big show. The Midway was the front door to the big show. The color and sounds of the Midway were an exciting part of the old circus.
Yes, they're all lining up. They're all buying tickets. One ticket pays the way to see it all. Hurry, let me get to go. It's a show for the ladies, the gentlemen, and the children. If you care to see the big side show, you're just in time, and this is the place. Hurry, little lad, be going. One ticket pays the way to see it all. No waiting in here. Boys, go in and start the show right now. Go right in there and start the show. There it goes right now. If you care to go, this is the first big show in your city today. Everything you see pictured and painted out.
After buying your ticket, you passed through the menagerie tent on your way to the Big Top. There were all kinds of sights and sounds here to thrill the circus fans. While the crowd was gathering, our circus trumpeter called us to get ready for the show. The backyard was a busy place as the performers hurried to get into costume. By circus tradition, each clown has his own special makeup, and no one else copies it. The circus animals were dressed with beautiful robes, feather plumes, and special harness. By showtime, all the performers were ready.
Ladies and gentlemen, the circus on parade.
Golden light under the canvas, and the dust and smells of the old circus are gone. But the acts are still pretty much the same. Oh, sure, there have been some changes, but the circus is still the greatest show on earth. And to have a circus, you have to have clowns.
Sorry, you guys don't like clowns. I forgot. There's a contingency on YouTube that's like, clowns, oh my god, clowns. It is, clowns are scary because they are grotesque people that make fun of us. and make loud noises. I get it, although I delight in it. So Emmett Kelly was featured in there. I don't think he's not the main clown. I don't think, but yeah, circuses are fascinating. They're not going to exist nowadays like they did because of the animal issues. But I think that there still will be people performing and doing fascinating things and awesome things. And that will still be something that people will delight in seeing. I went to a tent circus when I was a little kid, and it was really quite something. It was a small circus. I can't even remember the name of it. It was really tiny. One-ring circus. But it was, the sights, the sounds, the smells, lots of elephant poop. Yeah, I remember that very well. So, all right. So this next film is, I just have been pulling films off the shelf when I go to the archive, ones I haven't seen, and this one's called Legacy. And in just kind of previewing it just a little bit, it's a Will Vinton claymation film, which is fascinating because we just did a project where we scanned some Will Vinton footage for the archive, for their estate, actually. I think there's a documentary coming out about his story. And so, small world. That's the way it is when you collect a bunch of something, is that there's all these connections being made. So here's Legacy. Enjoy.
After the cosmic bang which set our universe in motion, after the fusing of clouds of gas into billions of giant stars, the gases that hovered about one star took form, and the planet Earth was born. In the beginning it was a dreary place, dry, barren, and airless. But natural forces were at work, and remarkable changes would occur. A veil of gases rose over the Earth, then cooled, condensed, and fell in rain. Millions of years of rain. Oceans formed. A bit of this and a bit of that, drifted for millions of years until an extraordinary thing occurred. Molecules began creating more of their own kind. The chain of life had begun. For millions of years, living things fell to the ocean floor. Billions of creatures of shell and bone falling, compressing, evolving to organic mud, and eventually to oil and gas. Then plants appeared on the land, and when they died, they returned to the earth. Millions of years of vegetation pressing and compressing one layer upon another, turning finally to layers of coal hidden deep within the earth. Meanwhile, in the sea, life was discovering new forms. It was a process of trial and error. Eventually, all of them died, returned to the planet and to the elements from which they were made. Then came new creatures that carried their young inside their bodies. Some were swift and some were strong, but one of them was clever. The world he entered was rich now, blessed with the vast resources that evolved from all previous life forms and matter. Oil and gas on the ocean floor, coal deep within the earth, minerals embedded in the rock, and vast forests. From barren rock and Eden. That was the legacy of 1 billion years, in a nutshell.
Fascinating. I like the early Will Vinton stuff, like Closed Mondays, and yeah, some of that early stuff is really great. He did do the California Raisins, which is regrettable, but I'm sure it made him a bunch of money. His story is a little tragic. He did pass away, but there was some shenanigans involving his company and I think the son of the owner of Nike, Phil Knight's son, where things were purchased and Will Vinton was kicked out. Anyways, I'm sure that's what the documentary is going to be talking about. But anyways, yes, an amazing amount of work. Another Pacific Northwest stop-motion animator. So Will Vinton is based kind of in the Portland, Oregon area. And another one, Bruce Bickford, who was based in Seattle. Also, I think he passed away, and he had an amazing amount of animation, stop-motion animation involving clay. Will Vinton coined the phrase, and I think trademarked the phrase, claymation. Wouldn't let anybody else use it. But, yeah, interesting. There you go. Let's see. What do we got? Speaking of air travel, let's see what it's like to travel by jet in circa the 50s. This is Airplane Trip by Jet.
This airport, like all big city airports, is a busy place, with planes coming and going day and night. Planes with propellers, and jet planes from all over the world fly in and out of New York's International Airport. Right now, Jet Flight 801 is approaching the gate where passengers for San Francisco will board the plane. A huge moving corridor swings into place. It is called a jetway. Through it, passengers can board the jet plane directly from the waiting room, safely and comfortably, regardless of the weather. The airport bus is already bringing passengers for Flight 801. But Sue and Bob Allen are at the gate ahead of time. They are taking their first airplane trip alone. The passenger supervisor, Mr. Peterson, is there to help them. They can be the first passengers to board the plane, he says, as he leads them to the boarding area. Grandpa Allen is a little worried.
You see, Mrs. Allen and I just couldn't make the trip to San Francisco.
Their parents, they've just found a house out there, and quite naturally, they want the children with them.
Really, there's no problem. We often have children traveling alone. Oh, by the way, let me introduce you to our stewardess. Miss Murray, Mr. and Mrs. Allen. This is Susie and Bobby.
Oh, it'll be fun having them on board. Say, it looks like you have another passenger here.
Oh, she won't be any trouble.
No, no trouble at all, except she can't ride in the main cabin. However, if she has a ticket, I'm sure Mr. Peterson will find room for her.
Flight 801, non-stop to San Francisco.
Grandpa and Grandma will have to say goodbye here, for only passengers are allowed to go out to the jetway leading to the plane. There's Mr. Peterson, just putting Skippy into a box, specially made for dogs and cats that travel by plane. Goodbye, Skippy. Goodbye, Grandpa and Grandma, shout the children. And they hurry on to find a seat in the big and comfortable cabin of the jet. Now the other passengers begin to board the plane through the jetway. While the passengers get seated, Bob and Sue turn to the many interesting sights of the busy airport. Mechanics check and service the big jet engines. Men load luggage into special containers, which are then covered and closed and driven to a loading hatch under the plane. One container after another is then lifted inside the plane and moved into place by a conveyor. Other men load the mail into the plane and food for the passengers. Through the window, Sue can see the traffic control tower. It is higher than the other buildings, so traffic officers can see the planes coming and going. Their job is to direct traffic at the airport.
Flight 801, use runway 21 left. Advise when ready to taxi.
Captain Mills replies,
Idlewild ground control, flight 801, ready to taxi.
Now the plane is ready to leave. Before takeoff, Miss Murray helps Bob and Sue fasten their seat belts. Seat belts make takeoffs and landings safer for the passengers. Just before takeoff, the pilot gets his final flight orders this way, and the dispatcher gives the all-clear salute, which means, go ahead. And off she goes from the loading ramp to the jet runway. Jets are so big that they need very long runways for takeoffs. And they fly so high that more air and oxygen must be added to the air in the cabin so that the passengers will be able to breathe comfortably. Before takeoff, the hostesses explain the use of supplementary oxygen equipment. Miss Murray points to the backs of the seats where oxygen masks are kept. She shows how to use the masks in case the air in the cabin should drop below normal pressure.
Place the mask over your nose and mouth and adjust the headband. Breathe normally and continue to wear your mask.
The captain pushes the throttle, and the big jet starts off. And finally, the wheels leave the ground.
Oh, we're flying! We're flying!
Soon they are high over the airport, the 4 jet engines working at full power. Jet engines have no propellers. The plane moves forward because burnt gases are forced out through the back of the engine. These jet engines have enough power to fly at almost 600 miles per hour. The jet is climbing higher and higher, leaving New York City far below. Captain Mills welcomes the passengers aboard.
Today we're going to fly at an altitude of 28,000 feet. Our flying time will be just under 6 hours.
Captain Mills, his first officer, and the flight engineer sit in the cockpit of the plane. The cockpit contains hundreds of instruments. These instruments help the pilot fly safely in the busy air lanes. Right now, the captain is setting one of the radio dials. But look who is coming.
Children, would you like to have some lunch?
Yes, please.
Oh, I'd love to. All right. Can you get your tray down, Sue?
Yes.
And while the jet plane flies over the green farmlands of the Middle West, the hostesses prepare lunch trays for their passengers. Here is one for Sue. And one for Bob. See how neatly everything is arranged on the tray? Meat, vegetables, dessert, and milk. Sue is enjoying her lunch. As the passengers eat, the plane continues its westward journey over the Great Plains.
Would you like to take a nap? No, thank you.
Airplane seats are comfortable. You can push the backrest down and curl up. Many passengers like to take naps. But Bob and Sue have too much to see.
Susan, would you like a junior stewardess pin?
Oh, yes, thank you.
And how would you like to be a junior pilot?
Oh, I'd love to.
Now Sue and Bob are glad they didn't take a nap.
Look now, we're flying over Denver.
Miss Murray thinks that a little walk through the plane would make a pleasant change for Sue and Bob. She is taking them to the lounge in the front of the plane. Sue finds a map on the table.
Miss Murray, where are we now?
We're exactly here, Susie.
This is First Officer Jennings. We are about to cross the Continental Divide.
The Continental Divide is a ridge of high mountains separating rivers flowing to the east from those flowing to the west. Sue wonders how the pilot can fly or find the airport in cloudy weather. Miss Murray tells her about the special instruments that guide the plane at night and in bad weather. Radio signals direct the plane on its way and to the landing field, almost as if it were gliding along a highway. The captain calls the San Francisco Center.
Over Lake Tahoe at 28,000. Flight 801 cleared to Oakland Omni. Cross Sacramento at 11,000 or above.
Susan, since you're a junior stewardess, would you like to pass gum for me today?
Okay.
What about me? Oh, I have a box for you, too. There's one for you, and this one for you, Susan.
Would you like to know?
Sue and Bob's parents are at the airport well ahead of time. The passenger agent has assured them that the airplane is already over the San Francisco Bay.
Fasten your seatbelts, please.
Already? Sue and Bob are surprised. Wasn't this a quick flight? Below, they can see the city where their new home will be. Sue and Bob can scarcely wait to see their parents. And here is the airport. Slowly and carefully, their jet approaches the landing field. And soon the wheels touch the runway in San Francisco. The ground control officer directs the plane to its proper gate.
Bye, Susie and Bob. You've been wonderful passengers.
Out go Bob and Sue, running to meet their parents. And here comes Miss Murray with Skippy. Bob and Sue can't wait to tell their parents all about their first jet airplane trip. Now they understand better why people say, we live in a jet age.
Yeah, wow. Thanks, everybody, for tuning in. Have a Ham, thank you so much for your donation of coffee. That's one way that you can support AV Geeks, is by keeping us caffeinated. Because I like coffee. It's good. Another way is you can hit like or subscribe. Go to avgeeks.com and see other stuff we have online. Tell people about what we're doing. Because we've been watching a bunch of films, and I'm so happy that you guys have been there to watch with us. I got one last thing. Yeah, we'll watch it. I can't remember if I showed this because of poor notes, but I have a bunch of TV trailers, things that were shown on television. And so here's some movie TV trailers. Let's watch those, and I'll come back, and then I'll say goodbye, and etc. So here we go.
Killer fish. From a robbery that's incredible, to a rendezvous that's undetectable, to a recovery that's impossible. On an island paradise, they search for treasure, they search for pleasure, and they search for flesh. Killer fish. The terror will tear you to pieces. Rated PG. Killer fish. A search for stolen jewels brings flesh-eating terror to the surface. Danger below. Disaster above. And death-defying survival every second in the most terrifying adventure to ever drag you in, pull you under, and tear you to pieces. Killer fish. Rated PG.
Jennifer is shy.
You need a friend, Jennifer.
I can handle it.
But please, don't make her angry.
I really don't think you belong here, Jennifer. And I'm personally going to see to your departure.
For if you do, you're going to die. Because Jennifer has the power. And she's a holy terror. Jennifer, rated PG.
New Granada, a perfectly planned community where something strange is happening. Something that wasn't part of the plan. Something that could drive this town over the edge. Over the edge, rated PG. New Granada, a perfectly planned community where something strange is happening. Something that wasn't part of the plan. Something that could drive this town over the edge. Over the edge, rated PG.
You have everything to look forward to, except tomorrow. End of the world. You are about to journey Beyond fear, beyond terror, in a major motion picture so frightening, it will devastate you totally. The Brood, David Cronenberg's ultimate experience in inner terror. They're waiting for you. The Brood, rated R. Was it an accident? Was it coincidence? Was it murder? Or was it an omen? Gregory Peck. Lee Remick. The Omen. Rated R. You have been warned.
So, a couple of things there. One is Over the Edge, which I love that movie. And I don't think it had a big theatrical release. I think it went straight to cable in most cases. The trailer makes it seem like something supernatural is going on with the kids. And, hopefully not a spoiler alert, but it's not supernatural. It's just boredom. Boredom drives kids to do what they do. So it's pretty great. And also, I just recently found the movie End of the World, which had that amazing trailer of the planet blowing up. And that is one of the most boring movies I've ever seen. It's so incredibly tedious. Christopher Lee's in it, but just barely. And it is just, there's like shots of this woman waiting outside in the dark for like minutes. It goes on and on and on. There's a scene where this guy is like sitting there looking at a computer screen and like typing and looking, and then there's like a little printout, and he looks again. And oh my god, it is so tedious. The story has potential, but they just drain any interest in it out. And there's probably only one or two really good scenes in the entire movie. And one of them is actually what's shown in the trailer. Trailers are the best because they really do show the most salacious, fascinating parts of the movie. But, so there you go. Thanks again, everybody, for tuning in. Very much appreciate it. I'm excited. Next week is my birthday. So I'm going to try to figure out something I'm going to do special for my birthday on Tuesday. I don't know what it will be. I'm not sure. But thank you for your support and your comments and all of that. It means a great deal every day to tune in or to broadcast to you guys, and you guys tune in, and we all enjoy. It's like we're in a room together, but really we're not. So thank you for that. What is the thing I'm looking for? Please rewind and love each other. And we will see you again on Monday. Everybody take care.